Today we're going to be talking about quadratics, their forms, how to factor, how to solve if you can't factor, how to view it on a graph, and an extra theorem that isn't widely taught in school but is a very helpful property and much faster if you're going to do something. So let's talk about the forms. We have three main forms. We have factored, standard, and vertex forms. And each of these forms can tell you something about your graph, or just about your equation in general. Now your factored, I should probably do that. It can tell you what your zeros are. That's why I marked x1 and x2. If you set these equal to 0, if you set x minus x1 equal to 0, and then if you set this one also equal to 0, you can find the so-called zeros or solutions of this equation. You can disregard a just because it's a scalar, as I mentioned in the previous video. It doesn't really have any effect, but it has effect on the look of the graph. So factored form can tell you the solutions of an equation. And the reason why you can set it to 0, I didn't explain, but is because of the zero product property, which means if one of these things equals to 0, because it's being multiplied, it's going to equal 0 as well. So the entire equation is going to equal 0 no matter what, as long as you have one of these things equal to 0. So let's move on to the next equation. Our standard form, it can tell us things as well as about our graph. We can have C, which is our y-intercept. And if we have negative b over 2a, that can tell us the center line, the line of symmetry on a parabola. And I'll show you how to apply that when we talk about our graphs. And then vertex form obviously tells us the vertex. The vertex point is h, k. And I'll tell you how to solve to find vertex form. Next, we're going to talk about factoring. So there's a few things I've learned when I've gone through Algebra 2. I've gone through it many times. This is also an Algebra 1 topic I learned from my Algebra 1 teacher when I was at North. But it's something I really haven't seen around at all. I haven't seen it anywhere other than that class. And when I do this specific type of factoring, some teachers give me weird looks. And I guess it's not really widely used, but it's a very efficient way to avoid guess and check. So it's not going to start with this. This is the basic way to factor, and we'll talk about the thought process behind it. But as soon as we get to a coefficient, then we get into this random way of factoring. So how to factor this is we want to list out. This is just at the beginning. Once you get the hang of factoring, you don't have to do this, but we want to list the factors of the last term. Disregard the negative sign, just think about the last term right now. So 12 and 1, 2 and 6, 3 and 4. Those are all the factors. Now, what is the combination of these numbers, or these pairs actually, it should be in pairs. What is a combination of these pairs that will get us, if you multiply, negative 12, but also if you add them together, positive 4? Now, right off the bat, because I've seen this so many times, I know that the combination of 6 and 2 will get us right here. And the way to factor this is I know that it's going to be a negative 2 because if you add 6 and negative 2, it's going to be positive 4, and if you multiply them, it's going to be negative 12. It's just something you really have to do a lot of practice of so you can quickly recognize it. So I'm going to say x plus 6, x minus 2 is our factored form of this equation. Now, this is the type of factoring that I was saying was kind of odd because I haven't seen it anywhere else other than that one teacher. It's called the slip and slide method, but basically what you need to do is you need to take this first factor and multiply it by the last one so that you get x squared plus 6x plus 8. Now you might be wondering, how is this going to work? It's never going to work. It doesn't work like that. No, it doesn't. I'll agree with you. Because once you factor this, it's not your final form. You need to do something next. So we're going to repeat what we did just before that. And we're going to do, let's say, 1, 8, 2, 4. These are our factors. So 2 plus 4 is 6, and 2 times 4 is 8. We don't have to worry about positive or negatives in here. So now we have x, let's say x plus 2, x plus 4. Now, you know that 2 we multiplied at the beginning to our 4? Well, we're going to divide by 2. And these come out nice and even. So now we have x plus 1, and we have x plus 2. And the reason why it came out so clean was also because you could really factor out that 2 anyway. You could take the 2 out and then just have x squared plus 3x plus 2. And you could have factored it that way. But if you end up here, let's say, we end up here, and for some reason it doesn't divide correctly. Let's say if it was like we're dividing by 3. So now we have x plus 2/3 and 4/3. What do we do now? Well, you're going to take this bottom term. If it cancels by any means, just cancel it. But if it doesn't, then you want to do 3x plus 2, and that's going to be your final whatever equation you're making. It's kind of an odd method, but it's a lot faster than just trying to guess and check your way there. So next we're going to talk about solving quadratic equations. Now, I don't think I have to really go over this because I'm sure a lot of you have heard of the quadratic formula, or at least just are a little bit familiar with it, or maybe some of you have memorized it. The quadratic formula is just based off of your a x squared plus b x plus c equation. You want to plug all of these numbers into this equation, and although it's a very surefire method of solving, it does take a little bit, and I only recommend doing the quadratic formula if you cannot factor whatsoever. You've tried every method and you just cannot factor. You want to use the quadratic formula. Now, let's talk about graphing. What's going on the graph? Well, let me tell you something. When you look at a parabola on a graph, take a look. You can actually determine how many zeros or solutions to the equation it has by how many times it touches the x-axis. And a parabola is going to maximally touch the x-axis only 2 times, and you can tell by the degree. X squared is only 2 times. You can only have 2 solutions. So This specific parabola we have here only has 1. And that's because it only touches once, right there. Now, let's say we're going to take this and we're going to move it down. Now it touches in 2 spots. 1, 2. It has 2 solutions. And finally, if it doesn't touch at all, it has no solutions. If you do the quadratic formula, you're not going to find any solutions to this. It's going to give you with a negative under the square root, which doesn't have any real solutions. Let's talk about, I forgot to mention this, but this right here is called a discriminant. And the discriminant also can tell you how many solutions you find. If the discriminant equals 0, it only has 1 solution. If the discriminant is greater than 0, it has 2 solutions. And if the discriminant is less than 0, it has no solutions. And just a few properties on the graph as well. If you use negative b over 2a, I'm going to say that this equation is x squared. Negative b over 2a, okay? Our a is 1, our b, we don't have a b, is 0, negative. So our axis of symmetry is just x equals 0. That line you're going to draw right down here is x equals 0, and that's the line of symmetry. So next, we're going to talk about this little theorem called Vieta's theorem. Actually, wait, before I do that, I'm going to talk about completing the square really quickly. Just to complete the square, this is helpful for finding vertex form, and what you want to do is just kind of try to make it into that form where it's x minus h squared plus k, and this actually equals that one property where a plus b squared equals a squared plus 2ab plus b squared. If you can memorize this, totally go for it, because it's going to help you so much to know. Whenever you're going to be factoring, or if you just see something, it's very common in math team or just any type of like competitive math in general. It's okay if you're not doing that. It's just very helpful even in regular math as well. So what we want to do is find it. Look at this. Right here, we can already see that we don't really need to do anything or add anything. It just works. So this is x plus 7 squared. And then 64, you want to do minus, that was a b, 64. And that's your equation. Now, what if you need to complete the square in a different way, where you need to add things on? Well, x squared plus, I'm going to make this up on the fly. I'm honestly not sure if this is going to work. We'll do 2x. Actually, no, we'll do 4x. We'll say 4x plus 2 equals 0. All right, well, now we gotta complete the square. So we're going to try to make this into x squared plus 4x plus 4, because then that will give us x plus 2 squared, and that's our completed square. I think not really a shortcut, but if you're unfamiliar with this, how to find that x plus 2, how to find this term, all you want to do is just take this middle term and divide it by 2. And that'll give you whatever term you're searching for. So, how are we going to do this? Well, we need to add things on. So, x squared plus 4x plus 2. How are we going to make this 4? We add another 2. But we can't just do that. We have to make it something else. Actually, I shouldn't have made it 0. I'll make it y. I'm changing this. I'll make it y. Well, since we're adding on to... Actually, no. I'll keep it 0. Sorry, I'm being indecisive. I didn't really plan this well. But because we're adding 2 to that side, we also have to subtract 2 from this side. So now we have 4 here, and we can do x squared plus 4x plus 4. We've got it. Now, I'm sure you're asking, what's happening to this minus 2? Well, the easiest way is you want to finish making this a square, and then move it to this side. And boom, just like that, you have your form. Actually, I removed it wrong. It should be plus. There's your vertex form, and then you have minus 2, comma 2 as your vertex. All right, we're gonna move on to a different topic that I just kind of talked about. Vieta's theorem. It's a very odd property, or not odd, but I'd say it's not really heard of in just regular school math. If you are doing math competitions, or if you're just very, very into math, this property you probably have been taught loads of times. But though people aren't really doing this for competitions, it's still pretty handy. I've used it many times in class. These kids are doing guess and check, and I just do Vieta's theorem. Easy. The teacher's wondering why I solved it so fast. That sounds like I'm bragging, but genuinely, this is a very time-efficient way of solving for specific problems that goes like this. Suppose a ball hits the ground twice at x equals 1 and x equals 5. So what we can gather from that is that these are our zeros. Okay? x1 and x5 are our zeros. Because it hits the ground, y is distance upwards, x is like distance horizontally. So it's going to hit the ground at x equals 1, x equals 5. Assume we're talking about like here, equals 1, negative 1, sorry. What is the equation of the projectile? Well, we know x1 said here. It doesn't really matter which one you pick as x1, just kind of follow it. x1 is 1 and x2 is 5. Plus 5 equals negative b over negative 1. We're going to cancel out our negatives. And the 1, you don't really need it, equals b. And then x1, which is 5, 1 times 5 equals c over negative 1. That gives us 5 equals negative c, so c equals negative 5. And I didn't write it here, but b equals 6. So our equation would be negative x squared minus, it's plus 6x minus 5. And that's your equation. So overall, quadratics can have a ton of properties, And if you just know how to manipulate these, or if you memorize or repeat these many times, you'll be able to think about these and just know them by heart. When you're doing things, don't have to worry. You just can free flow, I'd say. I don't know if that's the right word, but you can just do whatever. You know what you're doing if you just learn these really well.